This is Fuzzy Road to Health, and I'm Fuzzy D. Today we're talking about the differences in how calories from different sources affect the body differently. A calorie is not just a calorie. The calories in, calories out model is deeply flawed. It does not work like the mainstream public and nutritional dogma suggests. I recently had a viewer comment on a video I did a few months ago where I'd been talking about my struggle with a weight loss stall. Her comments were interesting but completely uninformed about modern research and the thousands of case studies in the low-carb community. This person trotted out the standard statements we often hear about calories in versus calories out. You know the ones, where they say if we eat more calories than our activity can burn, we will gain weight. They completely ignore evidence from the doctor I pointed them to that talks about this. Apparently this person only listens to mainstream science and nothing else means anything. Here are some screenshots of the conversation. Unfortunately, most people won't look at new research because they have been convinced they know the truth and refuse to look. It's why so many people stay sick or fat even after they are exposed to the truth. This is why we need to do our best to educate the public, our friends, family, and our politicians. Some of the studies I am presenting are more impactful than others. I will go into more detail on these stronger studies while giving just a TLDR on the others. The studies are all linked in the description below and the matching TLDR summaries. I have many of the actual PDF files of the study papers, which will be linked below as well. We need to talk about how studies are done and why the results from certain studies don't prove what they say they do. So there's the following 4 primary types of studies: critical review study, epidemiological study, clinical trial study, and RCT study. So here's a little bit of explanation on these definitions. So I went out and looked these up online on different sites, and this is kind of what I ran across, and then I also make my own comments about my thoughts on this. So a critical review is a way of reviewing prior and existing studies. It can cover and discuss the main ideas or arguments in a book or an article. Or it can review a specific concept, theme, theoretical perspective, or key construct found in the existing literature. However, the key feature that distinguishes a critical review from a literature review is that the former is more than just a summary of different topics or methodologies. It offers more of a reflection and critique of the concept in question and is engaged by authors to more clearly contextualize their own research within the existing literature and to present their opinions, perspectives, and approaches. Given that a critical review is not just a summary of prior literature, it is generally not considered acceptable to follow the same strategy as for a literature review. Instead, aim to organize and structure your critical review in a way that would enable you to discuss the key concepts, assert your perspectives, and locate your arguments and research within the existing body of work. The problem: if the critical summary is based on a flawed study, the review is meaningless. Epidemiology. Epidemiology is the study and analysis of the distribution, who, when, and where patterns and determinants of health and disease conditions in a defined population. It is a cornerstone of public health and shapes policy decisions and evidence-based practice by identifying risk factors for disease and targets for preventative health care. Epidemiologists help with study design, collection, and statistical analysis of data, amend interpretation and dissemination of results, including peer review and occasional systematic review. Epidemiology has helped develop methodology used in clinical research, public health studies, and, to a lesser extent, basic research in the biological sciences. The problem: at its core, this research is just looking for patterns in statistics. On their own, these studies actually prove nothing and should not draw final conclusions. The best use of these studies is to provide enough information to design a proper cause and effect study. The issue is they often publish these studies as if they were fact, relying on those conclusions to set public policy as a basis or to lobby the government. These ridiculous studies are often used to smear other research or the researchers. The general public don't understand the massive differences between RCT trials and the correlation nonsense found in epidemiological studies. That is why the public get confused and just tend to accept the popular narrative they heard their whole life. The powers that be and the media wouldn't lie to us, right? This is how they gaslight and brainwash us into believing their food lies. Clinical trials. A clinical trial is a research study involving human participants that evaluates the safety and/or effects of one or more interventions on health outcomes. Interventions include, but are not limited to, drugs, vaccines, radiopharmaceuticals, cells, and other biological products, surgical procedures, radiologic procedures, devices, genetic therapies, natural health products, process of care changes, preventative care, manual therapies, and psychotherapies. Data from clinical trials can be used to support the approval of drugs or to compare different medicines or treatments. The data can also help us determine which treatments are best for specific populations. These studies actually can prove or disprove a theory. It uses proper scientific methodology that is reproducible by other researchers. This type of study does not randomize on high participant details from the researchers. This does make it possible for bias to remain, but less likely. RCT, or Randomized Controlled Trial Studies. A randomized controlled trial is a form of scientific experiment used to control factors not under direct experimental control. Examples of RCTs are clinical trials that compare the effects of drugs, surgical techniques, medical devices, diagnostic procedures, diets, or other medical treatments. This type of study is virtually identical to clinical trials, except the participants' information is kept hidden from the researchers and their order of participation randomized. Other factors. Other factor to consider when reading or studying research is who funded the study. Do they have a vested interest in the outcome? For example, can we trust a study about the safety of sugar if it's funded by a company that refines and sells sugar? We need to apply critical thinking when considering scientific evidence. So now for some study papers. So this first paper that's up is Calories Do Not Add Up. It's not a really long article, but there are links to references and citations and whatnot. So it's a pretty good article. So the paper Calories Do Not Add Up presents several important conclusions regarding the understanding of calories and their impact on body weight and health. Here are the main points derived from the provided contexts. Ambiguity of caloric value. The phrase "a calorie is a calorie" is misleading. While it may seem true in a simplistic sense, it fails to account for the different biological effects that various food sources have on the body. For instance, a calorie from protein like salmon behaves differently than a calorie from refined carbohydrates like white rice or alcohol, in terms of metabolism and weight management. Physiological differences. Different macronutrients, proteins, fats, carbohydrates, and alcohol have distinct effects on physiological pathways and hormones that regulate appetite and body weight. For example, they influence hormones such as ghrelin and leptin, which are crucial for hunger and satiety. Critique of standard dietary advice. The traditional advice to eat less and move more is deemed impractical and biologically flawed. The authors argue that this approach does not consider the complexities of calorie absorption and expenditure, which are interconnected. Reducing calorie intake often leads to compensatory mechanisms that can hinder weight loss efforts. Focus on food quality. The paper emphasizes the importance of dietary constituents that are rapidly absorbed by the body. Highly processed foods, particularly those rich in sugars and starches, may contribute to overeating and obesity due to their neurohormonal effects, suggesting that the prevailing theories about calories and weight management are fundamentally flawed. They advocate for a broader understanding of how foods are prepared, combined, and consumed, rather than focusing solely on caloric content. In summary, the paper challenges conventional wisdom about calories, highlighting the need for a more nuanced understanding of nutrition that considers the biological effects of different food sources and the complexities of human metabolism. So our next one here is dietary sugars, a fat difference. Now this is a clinical trial, and the TLDR, it is demonstrated that consumption of fructose sweetened but not glucose sweetened beverages for 10 weeks increases de novo lipid synthesis, promotes dyslipidemia, impairs insulin sensitivity, and increases visceral adiposity in overweight or obese adults. Now, adiposity is basically the amount of fat in your tissue. Adipose tissue is fat. So our next study is dietary fructose and glucose differentially affect lipid and glucose homeostasis. This is a short-term clinical trial, and the TLDR to decrease the current high prevalence of obesity, dyslipidemia, insulin resistance, and diabetes. The focus should be on restricting the intake of excess energy, sucrose, HFCS, and animal and trans fats, and increasing exercise in the intake of vegetables, vegetable oils, fish, fruit, whole grains, and fiber. Now, it's interesting in this study because if you go through it, it looks like they're going to be trying to tell people they shouldn't be eating meat and they should be eating vegetables and fish and fruit and whole grains and all this type of stuff. But when you start going through this and looking at the citations and some of these articles that are linked to it, you start to see that that's not the results that they got. So they were looking for a particular result and they didn't get it. And they were at least honest enough to publish the study and the citations. So make sure you take a look at that. Okay, and this research is why do sweets fatten our livers? This is a short-term clinical trial. So the paper presents several important conclusions regarding the impact of excess dietary sugar on liver health and metabolic processes. Here are the key takeaways. Link between sugar and fatty liver. The study establishes a direct connection between high dietary sugar intake and the accumulation of liver fat through a process known as de novo lipogenesis, or DNL. This pathway is uniquely stimulated by dietary sugars, indicating that excessive sugar consumption can lead to fatty liver disease. Metabolic consequences of sugar intake. The findings highlight that increased sugar consumption not only contributes to weight gain, but also leads to significant metabolic disturbances, including dyslipidemia. Now, I thought we should take a quick moment and actually look up dyslipidemia. So if you have dyslipidemia, it usually means your LDL levels or your triglycerides are too high. It can also mean your HDL levels are too low. So that's what they're talking about there. Now, unfortunately, this study doesn't talk about the differences in LDL cholesterol molecules based on whether you're eating sugar and carbs or not. It completely changes the structure and the body is affected differently. So I've already got a video on that subject, so if you're interested in that, I'll either put a link up here or I'll put a link at the very end or in the description, or all of them. To carry on, this condition is characterized by elevated plasma triglycerides and altered lipid profiles, which can accelerate the risk of atherosclerosis. Reversibility of changes. Importantly, the study shows that the adverse effects of high sugar intake, including increased liver fat and dyslipidemia, can be reversed through a hypocaloric, low-sugar diet over a 6-month period. This suggests that dietary modifications can have a substantial impact on liver health and metabolic function. Correlation between the lipogenic index and liver fat. The research indicates a positive correlation between the increase in the lipogenic index, a measure of fat synthesis, and the rise in liver and serum triglycerides. This relationship underscores the role of dietary sugar in promoting fat accumulation in the liver. Genetic factors. The study also explores the influence of genetic variants, particularly the PNPLA3 gene, on the metabolic response to dietary sugar. It suggests that individuals within certain genetic predispositions may experience different levels of fat accumulation in the response to high sugar intake, warranting further investigation into genetic interactions with diet. Public health implications. The findings support public health recommendations to limit dietary sugars, emphasizing the need for awareness regarding the potential health risks associated with high sugar consumption, particularly in relation to liver health and metabolic disorders. Key results of the study on overeating and body composition, part of that clinical trial. The study conducted by Bray and colleagues provided scientific insights into the effects of protein intake on body composition during periods of overeating. Here are the main results. Weight gain variability. Participants who consumed a low-protein diet gained significantly less weight, approximately 3 kilograms, compared to those on normal or high-protein diets who gained around 6 kilograms. This indicates that protein content in the diet can influence the amount of weight gained during overconsumption of calories. Fat mass versus lean mass. Despite the differences in total weight gain, the increase in total body fat was similar across all groups. This suggests that excess calories consumed, regardless of protein content, primarily contributed to the fat mass accumulation rather than lean body mass. Energy expenditure and body protein. The study found that resting energy expenditure and body protein levels increased significantly only in the normal and high protein groups, while the low protein group did not show these increases. This highlights the role of protein in enhancing metabolic processes during periods of calorie surplus. Implications for obesity. The findings suggest that diets low in protein may lead to greater fat deposition and a potential loss of lean body mass, even if overall weight gain appears less pronounced. This has important implications for understanding obesity and effectiveness of dietary strategies for weight management. Diet composition and health risks. The study emphasizes that the Western diet, which is often high in fats and carbohydrates but low in protein, may contribute to the obesity epidemic by promoting fat accumulation. It suggests that assessing body fat rather than just body weight or BMI could provide a better understanding of obesity-related health risks. These results underscore the importance of protein in dietary strategies aimed at managing body weight and composition, particularly in the context of overeating. So what does all this mean in a nutshell? This boils down to how we have been deceived about how calories work. The amount of calories consumed has little to do with numbers. It has to do with metabolism. When we eat sugar, our body spikes insulin to compensate. When insulin levels are elevated, the calories just consumed can't be used directly by the body, so the energy is stored as fat. It is basically impossible to burn your own body fat with elevated insulin levels. It is insulin resistance and eating carbs and sweets that block our ability to lose weight. It has little relation to the number of calories, but to the type of food the calories are derived from. High-intensity exercise is great for flexibility, increased muscle mass, and overall health and well-being. Unfortunately, it is a terrible way to lose weight. To permanently lose weight and get healthy, you need to change the food you eat and your lifestyle. Now, I eat in excess of 4,000 calories a day in meat and fat, yet I still lose weight. So far, I've lost over 240 pounds. There are an increasing number of doctors knowledgeable in lower zero-carb diets, and many are fully carnivore themselves. Now, I should note that right now, because of issues with my neck and my back, I'm not exercising for the last few months. And yet overall, I'm still losing weight. I have days where I'll gain a pound or two, and then I'll stabilize for a day or two, and then I'll start losing weight again. If I have a day where I have, a little dairy or something, that often stops my weight loss. I'm trying to stay away from dairy all the time now. But occasionally, if I'm cooking for myself and my wife, sometimes I'll add a little bit of dairy for the both of us. So that's just kind of the way things happen. Check out the following doctors if you want to get an official medical take on this diet based on real research and experience. Dr. Ken D. Berry, carnivore, and he's an MD. Dr. Anthony Chafee, who's a carnivore and also an MD and neurosurgeon. Dr. Sean Baker is carnivore. He's a medical doctor and an orthopedic surgeon. Dr. Robert Kiltz, I believe he's keto or ketovore. And he's a medical doctor and a fertility specialist with one of the highest success rates treating fertility issues. And he treats them usually with keto or carnivore diets. Dr. Christina Mathewson, who's a naturopath and also a carnivore. Dr. David Diamond, who's an MD and PhD and a well-known researcher who's involved in a lot of this type of research. Dr. Timothy Noakes. He's an MD that specializes in diabetes, and he did a lot of the pioneering research in showing how you can heal type 2 diabetes by eliminating sugar and carbs. And you can even significantly help type 1 diabetes and stabilize it with the carnivore diet. Now, a lot of medical doctors say that's false, that diet doesn't affect your diabetes. But a little just common sense thinking refutes that idea. I mean, it just doesn't make sense. If you eat sugar, it spikes your insulin. If you spike your insulin, you're hurting yourself if you've got diabetes. It's pretty simple. So as always, if you have questions, feel free to drop them in the comments below or reach out via social media or email. My website is listed on the screen and in the description below. It has links to all my other platforms. If you feel I've earned it, please take a moment to like, subscribe, and hit that notification bell so you don't miss future videos. See you on the next video, my friends.